Why do you want your app to respond to remote control events? Well, principally you want to respond to remote control events because of the Apple earphones. The Apple earphones have a remote control on them, and this control allows the user to play, pause, switch to the next track, or go back to the previous track, among other things. Why do you want to respond to these? Well, if your user is listening to and watching the video in your app while they're on the subway or riding in a car with other people, they don't want to disturb their neighbors with the audio. And if they've got that remote control available to them, they want to be able to use it. Now, there's a couple other reasons that you might want to support the remote control events. If you decide to have the audio portion of your movie play in the background, then there are two ways that the user can control. When the screen is in the locked state, if the user double clicks, they can get the playback controls. Or if the user is using another app and goes to look at their most recently used apps list, they can swipe over and actually have another set of controls that we call the Now Playing controls. So how do you support remote control events? Well, first of all, your View or View Controller class needs to implement the Can Become First Responder method. Return yes. And then you need to do something when your view appears and when your view disappears. When your view appears, you need to tell UI application that you're ready to begin receiving remote control events. And you need to become the first responder. Only the first responder gets the remote control events. Now, when your view disappears, you need to undo these things. Tell UI application that you no longer want to receive remote control events and resign first responder. Now, when you get a remote control event, your method called remote control received with event is what's going to be called. You're going to look and see that the received event is a remote control, and you're going to look at its subtype to see what kind of remote control event it is. The one that I've highlighted here is UI event subtype remote control toggle play pause. This is the most important one to respond to. Typically, whenever the play pause button in all of these interfaces is going to give you this event. On the slide, I've listed a couple of other events, the previous and next track events, but there are several other events that you should handle, and you need to refer to the documentation for those. The next thing I'd like to talk about is how you can get video output from your application. Now, with the iOS devices, you're not actually getting a video output. Instead, you're getting a second screen. And this happens whether you're using the VGA connector or the composite or component AV cables. In terms of your application, what you're seeing is a second screen. And that screen is just another view. To handle UI screen, you need to register for screen connection and disconnection. And then when you want to display content on that screen, you create a window and simply associate the screen, that external screen, with that window. You add whatever views you're interested in and show the window to the user. So let's take a look at that. Registering for screen connection and disconnection should look a lot like what we've seen before. We're just adding another observer, in this case for the UI screen did connect notification, and there's no object associated with this. We'll also register for screen disconnection. Now let's look at our method that we're going to use for handling the screen connection. The notification object associated with the notification is going to be that new screen that's been connected. We're going to allocate a window associated with that screen and set the screen as the screen object for that window. Once we've done that, all we need to do is tell our application to adjust the UI for having that second screen. Now, when we get a screen disconnection notification, we essentially do the inverse. We need to hide that window, get rid of it, and update our UI to reflect that that window is no longer there. Next, I'd like to talk about AirPlay. Now, AirPlay was something that we added in iOS 4, but now in iOS 4.3, your application has the ability to send video over AirPlay. Now, one thing that trips some people up is that you always will see the AirPlay button whenever there's an AirPlay device around, even if that's only an AirPlay audio device. AirPlay audio is something that you don't opt in or out of. It's always there. You do, however, have to opt into AirPlay video. You do this with the Allows AirPlay property on the MP Movie Player controller. You simply set it to true. Now, do remember that AirPlay in your app requires updated software on your Apple TV. You can use AirPlay with web content by setting the appropriate attributes in your HTML. And while it's supported with Media Player, it's not supported in AV Foundation at this time. You can use it with HTTP live streams, but if your stream is using encryption, that's not going to work over AirPlay. And one thing you have to remember is it's streaming the movie, not the screen. If you're doing overlays or backgrounds, those things are not going to show up on your AirPlay device. So I've talked about 5 different enhancements about how you can customize your user interface, about the extensive movie notifications, handling remote control events in your app, how you can use a second screen, and AirPlay. Now I'd like to make a few digressions. First of all, I'd like to go back to our technology framework and talk about another framework that I didn't mention before, and that's the Audio Toolbox framework. Now, the Audio Toolbox framework lives underneath the AV Foundation framework and Media Player. And the reason I'm mentioning Audio Toolbox is because of what's called the Audio Session category. The Audio Session category, what is it? It's an identifier that tells the system how your application uses audio. It tells the system what kind of behavior your application expects. Do you want to receive audio input or produce audio output? Do you want to honor the ring silent switch? And do you want to mix with any other audio that may be on the system? You have to remember that you're in an audio environment, whether you like it or not. The user may have been playing some other audio before they switch to your app, and it may be appropriate for your app to allow that audio to continue playing. So there are 6 audio session categories, and remember, you set these based on the role that audio takes in your app. The first one is playback. If you're doing audio or video playback, that's where you should be. If you're simply recording, you want to use the record category. Now, if you're doing something where you're doing a combination of playback and record, for instance, a voice over IP app, you'd want to use the play and record category. If you happen to be doing something just with audio, some offline processing of audio, you'd use the audio processing category. And the last 2 categories, ambient and solo ambient, are mostly for games and productivity apps. Now, these are the only 2 categories, ambient and solo ambient, that honor the ring silent switch. And the reason they do so is by using one of these categories, you're telling the system that audio is not that important to your app, and it's all right if it be silenced. The important takeaway here is you need to understand the audio session category, because the default is solo ambient. And if you're playing movies, that's probably not the right thing for you. The next thing I want to mention is differences in movie containers have effects that percolate all the way up to the API. Now, there are really 2 different kinds of formats. There's HTTP live streams and other formats. Now, rather than saying something that long, I typically talk about HTTP live streams just as streams and other formats as files. Now, this is a bit of a misnomer, but it's good enough for our purposes. If you haven't used HTTP live streaming previously, I recommend that you visit our page dedicated to HTTP live streaming, developer.apple.com/resources/HTTP-streaming. This has pointers to all of the documentation, videos, and sample code, and the specs related to HTTP live streaming. Now, streams and files have a lot in common, but there are some differences. For instance, streams and files can be in different locations. Streams have to be fetched with HTTP or HTTPS. Files, on the other hand, can be local on your device or fetched over the network. There are also differences in features. The kinds of tracks and other aspects of the movie are different between streams and files. And lastly, these differences do percolate into your code and make differences in how you code. Let's talk about the commonalities between streams and files. First of all, the preferred codecs. For video, it's H.264, and for audio, it's AAC. Yes, there are other codecs that we support, but these are the sweet spot, if you will. In your video, you can go up to 720p and up to 30 frames per second. And the audio, 48 kilohertz sample rate and up to 160 kilobits per second data rate. In terms of differences, with streams, you can have timed metadata. That is, metadata that's associated with particular moments in your video. This doesn't exist in files. On the other hand, with files, you can have multiple soundtracks, you can have subtitles, in fact, multiple subtitles, and you can have chapter markers. These things don't exist with HTTP live streams. Now, in both streams and files, you can have closed captioning. The next digression I want to talk about is you need to think asynchronously. In video, lots of things are happening behind your back, being done by the system. For instance, when you get to AV Foundation, you're going to use something called asynchronous key value loading, where you ask the system to fetch a value out of your movie. You're going to get a reply asynchronously with the information. As I mentioned when I was talking about notifications, if you're generating still images from your movie, that's going to happen asynchronously. You're going to get an asynchronous notification that those still images have been created. If you're making another copy of your movie, exporting it in some different bit rate, again, you're going to ask the system to do that on your behalf, and it's going to notify you asynchronously. And in AV Foundation, you're going to be using key value observing, which by its very nature is asynchronous. The other piece of asynchrony is multitasking. Your app is going to live with other apps on the system, and your app may be pushed into the background by the user. You have to realize that if the user starts up